record. There it goes. Okay. So number 8. It says, I wouldn't even read it anymore because at this point it'll probably confuse you more than since you know how to do these. All right, so the way we do these, math modeling, we put this in our calculators, right? Okay, so grab yourself a calculator. On your y equals button, make sure all these plots are empty. Okay? If they're on, you'll see one of them highlighted. You guys are pretty lucky because class before you probably clears them out. In fact, they may even put the problem in. Make sure they're not highlighted. All you have to do is go to it and hit the enter button and it turns it off. Okay? Next thing you're going to want to do is hit the zoom key. Make sure you're in zoom standard because those AP Stat students are going to change the windows on you. Hit enter and make sure you go back to your default graph. Okay? So we're going to go ahead and put this in our y equals. Let's see, we've got negative, and please use the negative key. Negative, not the minus. 16, we're using x squared plus. Now you might have to arrow key out of the exponent, so be careful. 143x, and then plus 4. Hit the graph key, and we're going to get probably something that's out of the window, right? And we do. So I'm going to get my parabola in the window, and I'm going to do that by hitting my window key, and I'm just going to mess with the Y max. Pardon me? Let me see. Oh, yeah, that'll work. I was just going to punch in something like 400. You know, put something in pretty large, because if you don't see it, you could always go back and put a smaller number in, right? Or a bigger number. Hit graph, and just make sure you can see the parabola in your window. Kaylina used 375, so she's probably got, maybe a little bit bigger of a parabola. All right. If it's too small, like your parabola is like this, you could always go back and change it and back to like 200 or something. Okay. So we got a pretty good picture of what's going on. Now, this is the easy part, right? Where we have a table and we go to fill it in. All we have to do is go to our table, second graph, and this is our x, right? That's our x, that's our y. So I'm going to go down here to x equal 2, and they want us to find y, which is 226. And number 3, when x is 3, our y is 289. And 4 is going to be 320. So that's like an easy A, right? Does anybody need a copy? Do you need a copy? No? You're good with this material? Okay. All right, so when they want us to know when the arrow hits the ground. Okay, so that's where it crosses our x-intercept, or our x-axis, which we call x-intercept. Call it, what else we call it? Roots, 0, zeros because y equals 0, right? Solutions, Okay, your calculator uses 0. So we need to go find the 0. Oh, got a lot of glare there. So I'm going to go back to my graph. And I'm going to hit second trace for the calculations. Going to go to the 0, hit enter. Now they want a left bound, right bound thing, right? So I need to, I'm trying to find my 0 down here, right? I'm going to get closer to it. And I'm going to hit enter for the left bound. And then I need to be to the other side of the x-axis or the right bound. So I'm just going to get over the axis, hit enter, and then enter again. And I get, let's see here, 8.97. And that's my answer. So that was math modeling. We're not. They're not going to ask us for the max or min, so we don't have to worry about that. Just the table and the x-intercept. Questions? All right, number 9 is just the opposite of number 5 that you did yesterday. Okay, this is vertex form, which is y, or the f of x, which whatever you want to use, is a, the slope, times the absolute value of x minus h plus k, where the vertex is hk. All right? Remember, h is opposite sign. So if I'm looking at this, my vertex is opposite the sign, so 4 is my h. My k is same sign, -2. So I got 4, -2 is my vertex. My slope here, my a, there's nothing there, so it has to be 1, right? My slope has to be 1 or 1 over 1. So I'm going to go up 1, to the right 1, up 1, to the right 1. Here's the right side of my V. And I have a line of symmetry here, so I'm going to go up 1, to the left 1, up 1, to the left 1. Here's my other side. Okay. Now, it doesn't say that you can't use a calculator. It says try it without it, right? You could put it in your calculator and graph it and do it from there too, right? Go back to your y equals, put in the absolute value, which, by the way, you have to hit the math key. You have to go over to num, and it's number 1 there. Hit enter. Absolute value of x minus 4 minus 2. I think your operating system might be updated on your calculators. You might actually have absolute value bars there. Graph it. And I didn't go back to Zoom Standard. I should have went to Zoom Standard. And there it is. Okay. You can get some points off your table. We know that the vertex here is 4, -4, right? And even if you didn't know it from here, you know, the equation, your y values start repeating. See how it's -1, -1, 0, 0. So you know that this is your vertex. So you could do it with your calculator. All right, next problem. Says solve for b. Okay, we have to isolate and solve for the variable they're asking for. The best thing to do here, circle what they're telling you to isolate. Okay? You notice here that I have b on both sides of the equal signs. That's a huge problem. We need to get them on the same side first. So I'm going to bring this AB term over to the left side by subtracting AB from both sides. That gives me, now I'm going to put the positive one first. These are unlike terms, don't combine them. So I have 5b minus AB. These cancel to 0, and I have 12. Now at least they're on the same side of the equal sign. I'm still going to circle them. And it tells me, hey, I have a b in two terms. So I need to get it out of there or divide it out, right? So if I took 5b and divided by b, but I have to do it to both terms, right? So what did we call this? Do you remember? Undistribute. AB, we're dividing out the b, I'm left with a. Then I'm going to divide, now that I have one term here, because this is locked in parentheses, it's being multiplied, so I'm going to divide by 5 minus a. So I finally get my b by itself. And on the right-hand side, I get 12 divided by 5 minus a. Now, number 11 is the whole reason why I split this test up into two parts. This is going to take you a while to do. Okay? There's a lot of work here. We have to find it. We have to find two of these problems that are equivalent to 3x to the 6th divided by 4y to the 3rd. Now, a lot of times students were pressured with time and they would just start circling them, and most students would get it wrong. What you have to do, you have to solve or simplify each one of these and then circle the ones that work. So that's what we're going to do. The first one. Okay, I've got 6/8 are my numbers. That can be reduced to, let's see, we could take 3 or 2 out of both, right? So I get 3/4. Good. Well, so far so good. I got 3/4. Now, the x's, so I have x to the 7 minus a -1, which is x to the 8th. Here we have an x to the 6th. So I could pretty much stop here, right? And say, hey, this ain't going to work, because I ended up with an x to the 8th, right? This next one, if I don't have an exponent there, it's 1, right? I have an exponent outside parentheses, so I have to distribute to each one of those. So I get 4 to the 1 times -3 is -3. Y to the 1 times -3 is y to the -3. Over 3 to the 1 times -6, it's -6. And then x to the 1 times -6 is x to the -6. So I'm going to go ahead and flip the entire thing, because every exponent's negative, right? So I'm going to put these on top, make them positive. 3 to the 6, x to the 6. 4 to the 3, and y to the 3. Now, the exponents work for the variables, but the 3/4 and the 3/6 to the 4/3, I don't know. It could reduce to 3/4. I need to, let's put that in a calculator, see what happens. So I'm going to go to my regular calculator mode, so I'm going to hit second mode, and I'm going to put in parentheses 3 raised to the 6 divided by 4 raised to the 3rd, and see if it simplifies to 3/4. I'm going to hit enter, I get a decimal, I'm going to hit enter, 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 and it doesn't. So all that work that we did to find out that this one's not going to work. Bummer. All right, next one. Again, if there's no exponent there, we're going to multiply. So I need to since both of these are in parentheses, so I'm going to multiply this to every one of the exponents. What's that going to do? Yeah, it's got to flip the whole thing, right? So I'm going to have 4x to the 6th on top and 3y to the 3rd on the bottom. And again, close but no cigar. Not going to work. Okay, now the next one. Again, we have exponents of 1 there, right? Outside parentheses. Going to have to distribute to each one of those. So I have 9 to the 1 times 1/2 is 9 to the 1/2. X to the 12 times 1/2. Well, what's half of 12? 6. 16 to the 1 times 1/2 is 16 to the 1/2. And then y to the 6, well, what's half of 6? Okay, any number raised to the 1/2 is actually taking the square root of that number, right? Square root of 9? 3. X to the 6. Square root of 16?
4.
Y to the 3. And lo and behold, these are the same. So I'm going to circle this guy. So what do you think is going to happen to this one?
It's going to be.
Yeah, it's going to be equivalent. Here's my numbers. 9/12 reduces to 3/4. My x's. X to the 9 minus 3 is x to the 6. It's positive, so it goes up on top. And then the last one, y to the 2 minus 5, y to the negative 3, and that's going to go on the bottom to make it positive. And they match. Takes a long time for that problem.
Basically, do this problem first on this day. Again.
No, you on the test tomorrow. Like that's why I split this up into 2 parts, so that you'll have plenty of time to get part 2 done. All right, factoring. This is where you're going to use your factoring flowcharts, right?
Shoot.
I'll get some made up.
Oh, no, I think I have it.
First thing that your factoring flowchart says, are there any common factors? Well, nope. Then you're going to go directly, because it's a trinomial, you're going to go directly to your factoring. There's only one way to get x squared, x times x, right? Factors of 14.
The 17.
Yep. We have a minus sign there, so we have one's got to be positive, one's got to be negative, so we're going to be subtracting them. And the only ones that are going to subtract the 5, 2 and 7. Now, since we have a 1 in front of there, it doesn't matter whether we put the 2 or the 7, or where we put them. In fact, you could probably figure out right now which one's going to be negative and which is positive. I have 2x, 7x. They have to add up to negative 5x. So the bigger number has to be negative. The 2 has to be positive. So negative 7 and positive 2. The other one, same thing. Nothing we can take out of all three terms. Go directly to your factoring.
Yeah,
Are you also counting the x squared?
Pardon me?
Are you also counting the x squared? Because if he does the first, the last two, then you can just go back to work.
I'm not following.
because 12 could be reduced by 2.
Yeah, but the x squared doesn't. You can't take. You can't take a 2 out of the x squared.
Okay, never mind.
You know what I'm saying?
Yeah.
Okay, so x times x. Factors of 20. 1 and 20. 2 and 10. 4 and 5. It's a positive 20, so it's either positive times positive or negative negative, which means we're going to be adding the two factors together, right? Have to add the 12, and yes, they have to be negative, so negative 2, negative 10. All right, 13. I wouldn't even read the problem. I really wouldn't. Because by the time you read the problem, it's just going to confuse you. Here's the equation. Here's our substitutions. 10, 8, and 2. Just put them in the z equals here. Okay. R is 10 plus my L is 8. Don't forget the I. 8I minus capacitor is 2I. Combine these two like terms. 10 plus 6I.
So they're 8 and 4 plus, so we just have
Yeah.
to set it out.
Yeah, by the time you read all this crap, you're going to sit there and say, oh my God, I don't know what that. Just look at the equation, your substitutions, do the problem. All right, now, number 14 is also going to take you some time. Okay? You guys remember solving systems of equations? No. Well, the first way there were three methods. By graphing, where you have an actual graph with, lines and you solve. The second one was by substitution, where you had one of the variables solved for. Okay? Or in other words, one of the variables is isolated. And then the third method was elimination, right? Where you added the two together and eliminated one of the variables. Okay. Well, looking at our problems here, our different equations, which one are we going to use? Substitution. And why? The y is solved for. Y is isolated, solved for, whatever you want to use. Y is alone. Okay. Now here's the long part. We have to find, they want a solution. So we have to actually do it, right? So substitution is, you take what y is equal to in the first equation, in this case y could be x, and you substitute it in where it is in the second equation. So I have 4x plus, now use parentheses, your y equal 15. And your substitution is 5x minus 3. Okay. We have a plus sign out in front, so we can drop the parentheses. Now I can combine like terms. I get 9x minus 3. Now what?
Add the 3 to the 15.
Good.
And then I guess we divide the 13 by 9.
18.
So 18 by 9 then.
Yep. So what does x equal?
2.
Okay. Be careful here. You're not done. Right? Because we got x equals a number, we have a solution. They intersect at exactly 1 point, right? And that 1 point, I know the x value is 2. I have to find that y value, right? So pick an equation. Top one, yeah. Y equals 5. This time I'm going to substitute in for the x. Minus 3. And x is 2. So this equals 10 minus 3, which is 7. So the second part's going to take a little bit longer. There's a couple of long problems on there, right? But you still have enough time to finish the test tomorrow. Any questions? Are we good? You're going to have to watch the video, okay, Mason?